Hello, good morning. So today I will be discussing to you the lesson 2, which is the strings. So these are the expected. These are the things that you need to learn after the discussion, this video discussion. By the way, I would like to discuss to you the basic definition of what are the content that belongs to the string. So I'll be discussing this to you later on, but first I will be having the basic definition of all the things or of all the content that is very important when it comes to the topic string. So since we will not be meeting today because some of your classmates attended the web design training, so I'll be discussing to you the most three most important topics under strings. So we have here, if we will are going to read this was uploaded to you earlier. We have the string, we have the alphabets, and then we also have the symbols. That is actually the content of this lesson 2 topic. So I'll be discussing to you the basic definition of the basic uh, definition of the following. So first, I will discuss to you what is a symbols. So when you see symbols, sorry, when you see symbols, symbols is actually is a character. So a symbol and a character are actually the same when it comes to strings. So symbols is a character. Let's say, for example, we have, let's say, we have this one na lang para mas mabo. We have, let's say, for example, this is example, same with example. So, A, B, C, up to Z is actually symbols. So, we have A, B, C are symbols. Same with numbers. So we have, let's say for example, we have 1, 2, 3, or up to 9. This is actually a symbols or a character. Each of these symbols is what you call a character as well. We can also have the special characters. We have the and, we have the percentage, we have the minus, or we have the plus. So these are special characters. All of these are actually what we call symbols. So these are symbols. So for a while has, so this is what we call, I want to look for, okay, here. So this is what we call, no. So this is what we call symbols. Wait for a minute. Okay, so these are what we call symbols. Each of these characters are considered to be a symbols or a characters. Now, how about alphabets? Next is the alphabet. So when we say alphabets, this is actually another definition of alphabets, since the one that we know commonly is when we say alphabets, it's A, B, C, D up to Z. But here in the string, when we say alphabets, it has another definition. So when we say alphabets, it is an alphabets. It is an alphabets. An alphabets, it is that is infinite or finite. Finite. So a non-empty set, a non-empty set, an empty set, a non-empty, empty, empty set of a symbol. Okay, so when you see alphabets in another meaning, so another definition of alphabets when it comes to language theory or when it comes to string, an alphabets is the a finite or a non-empty or a non-empty set of a symbol. So when you say that a non-empty symbols, let's say for example, we have, by the way, alphabets is actually denoted by a sigma. A sigma, I actually have pasted here, this one. So when we say alphabets, it is denoted as sigma. So this is the considered to be as the alphabets. So let's say for example, since we defined alphabets as a finite or a non-empty set of a symbol, therefore example for this are, let's say for example, we have sigma or alphabets is a set of 0 and 1. So when we say finite, I defined alphabets as a finite. When we say finite, the definition of finite is actually finite is defined as having limits or bounds. So let's say for example, when we say like our age, di ba? We have a lifespan. So it has a limit, or when we say bounds, it will end. Okay, when we say forever, it is a infinite. But when we say a set of numbers or a set of characters or a set of string or a set of characters, that is what we call finite, because it ends and it has limits to how are we going to get the combinations of numbers. So finite is defined as having limits or bounds. So when we say, for example, when we say sigma is equals to 0 and 1, this is a set of binary numbers. This is considered to be a set of binary numbers. A set of binary numbers. When we say, let's say, for example, this is example A, and then we also have example B. So let's say, for example, another example is sigma or alphabets is a set of, we have A, comma B, and comma B, comma B, A, B, 2. Okay. Oh, what happened in my phone? B, comma C, up to Z, right? So when we have sigma is equals to ABC up to Z, this is considered to be a set of all alphabets, right? A set of all alphabets. And we can specify this as a set of all lowercase alphabets, because when we say uppercase, it's another characters, it's another specific symbols. So we have to specify as a comma a set of sigma A, comma B, comma C to Z is a set of all lowercase alphabets. Now, how about numbers or special characters? We have a set of sigma is a set of characters. We have plus, minus, we have and, or we have percentage. These are a set of special characters. Special characters. Now, if you're gonna add all the characters, it will be all a set of all special characters. But this one is actually just numbers from, we can actually put all the set of up to all the sets, and then we have two, we have like that, or all the specials. This is available. So we can say that a set of all special characters. Now, these are the example of the alphabets. So this is another definition of alphabets, since the basic definition of alphabets is actually is each characters you will call it as a symbol. So let's say for example here we call this as a symbols. Each of the characters or symbols that is included in a set, we will call this symbols. However, a set of those symbols, this one, let's say for example, a set of all these symbols is what we call alphabets. Okay, so this one, each of these, we can call this as a symbols. This is actually a symbols. So, mo ni gitawag na to nga symbols. This is symbols. But when it is included all the symbols in a set, this is what we call a alphabets. So again, alphabets is it is an alphabets that finite that consists of finite or a non-empty set of a symbols. Non-empty set meaning to say na ay characters or na ay symbols in a set. This is what we call an alphabets. So again, the basic, this is too big. So the basic definition of an alphabets is that each character is, I have to get it smaller. Each character is considered to be as a symbol. So mo na akong gimension diri. All of these are symbols. All the elements or all the symbols or characters in a given set, that's it, what we call the symbol. And a set of those symbols is what we call alphabets. Okay, so this is another definition of alphabet. So each symbols or each characters is called the symbol, and then the complete set within all of those symbols are what we call alphabets. Now the next that we need to define is the string. We have number 3, strings. Okay, so when we say string, a string is actually a finite set. Same with a character, it is a finite set. Sequence of symbols, it is a sequence. It is a sequence of symbols. It is a sequence of symbols chosen from some alphabets. So let's say for example, alphabets. So diba, we have sets from the alphabets. Let's say for example, these are the example of our finite set of alphabets, or the sigma. So everything, all alphabets are denoted by sigma symbol. So we have 0 to 1 is a set of binary numbers. A, B, C, and Z to Z is actually a set of lower case alphabets. And then we have sigma, or the alphabets, a set of special characters, of all special characters. So when we say string, a string is a finite set, meaning to say a set that has limit or bounds and it is a sequence of symbols taken or chosen from the alphabet. So let's say for example, we have example A. So we have 0 1 1 0 1 1 1 0. So this is taken from the example A from the alphabet. So this is actually coming from you have to copy paste the symbols. So this is from the alphabets 0 and 1, 0, comma 1, right? Because all of the combinations, all of this set are actually chosen from the set of binary numbers, which is considered to be the alphabets. So when we say 0 to 1, when we say string magod, it's actually a word, a string or a word. So coming from this set of numbers, you can already create like the ASCII code. These symbols are actually represented by numerical or numeric equivalent. So when we say string, a string is a finite set that is a sequence of symbols coming from the alphabet. So when we get the combinations of this, all of these are actually found in the set of binary numbers from this set. Let's say, for example, we have AA, BB, AA, and then we have cub. This is actually from the set of all, or from the set of all. Gonna get this A so that dili ta medyo maglibog. So we're gonna put this as like that. So this is actually from the set of, we have A, B, and C, right? Because all of this sequence of symbols are coming from sigma A, comma B, comma C. All of these are found in this set. So whatever combinations that you can come up from the set, as long as all of the symbols and characters can be found in the set. Okay, and then we also have letter C. Example, we have, let's say for example, symbols, and then we have this one, these symbols. These are actually, no, plus, we have minus, we have and. They can actually from the set of this one, we have plus, minus, and or the special characters. These are actually coming from the special characters. So that's how the basic definition or the basic content of lesson 2, the string. We have symbols is a character. So all of the symbols that content or that belonging to a set is what we call symbols. And then when we see alphabets, another definition of alphabets from the common alphabets that we know. So the another definition of alphabets, it is an alphabet that is finite, meaning to say it's not empty. It's a non-empty set of symbols. So when we see finite, it is defined as having limits or bounds. So let's say for example here, you can only get a sequence of symbols coming from the set of alphabets. So if these symbols, or if this sequence of symbols are not coming from these alphabets, meaning to say it's not totally what we call the string coming from the chosen alphabets. So when we say alphabets, examples are a set of binary numbers 0 to 1. We know that 0 to 1 is the set of binary numbers. And then we also have a sigma A, B, C to Z, a set of all lowercase alphabets. Same with the uppercase alphabets. It's actually a different characters or as a symbols. And then we also have sigma is equals to plus, minus, and all the other special characters there is. So this is what we call a set of all special characters. So when we defined symbols from an alphabets, the basic definition is that each character, this one, each character is considered to be a symbol, and a set of these symbols is what we call alphabets. Now, on the other hand, we have string. When we say string, string is actually can be a word or a string. It could be a string or it could be a word coming from a set. So let's say, for example, a string is a finite set. It is a sequence of symbols chosen from an alphabet. I have one example here, which is let's say, for example, uh, this one, we can have this up to Z. So we can actually get a word here, which is cat, because cat is actually belongs to all the alphabets. We can also hear a dog or a bee or any other words. So when you see string, is actually a string or a word coming from or chosen from an alphabets. But if you're gonna do only this, kung diri ra kataman, you can actually have it, you can actually make a word out of it, like a cab, from an alphabet or a sigma A, B, and C. So again, a string is a finite set. It is a sequence of symbols chosen from an alphabet. So it could be a string. It could be a with a sense, or without a sense, a combination of words or sequence of symbols, or it could be with a sense, like a word that has meaning on it. Okay, so this ends the discussion. That that's all for the basic definitions of a string. Next definition or next video discussion will be uh, a little bit about the concentrations or all of the other uh, lessons that is defined or that are actually like this one, the concatenation and associative, which is actually gathered, or which is actually derived from the formula that I gave you, or from the seven. I think that it has seven. So that is all for now. I hope you will be able to understand what I'm trying to say with this basic. These are just the basic. We have the symbols, alphabets, and strings. Thank you once again, and I hope that you will listen and you will study the lessons I gave you. Thank you and have a great day to all.